Hello, this is Mina, and I'm gonna explain our final project for data science course at George Brown College. And my thanks to Dr. Deepaj for providing the best for this course. Also, I'd like to say that I'm recording this video on behalf of my other teammates, Gelar and Emir. We made predictions using logistic regression with the Wisconsin breast cancer dataset, if I'm not mistaken about the pronunciation. First of all, and as always, importing pandas as PD and reading the CSV file, and here using the head method in order to see the first 5 rows of this data and put all my data in my DF. And then, as I think this column, the type of this column is string. The data type of this series is put string, and then describe methods, and you can see some statistical things here like mean, max, count, and so on. And as you can see, the shape of my DF is 699 row and 11 columns. And then using tail and then is null in order to find the missing value, the NaN value, and as I said, the type of this column is not numeric like integer or float. And then, so in order to be able to use all the data, we set this column. We convert this column to numeric using numeric method, and errors equal to curves in order to replace all non-numeric values to NaN. And I'm not sure that we did it correctly. We made a mistake. And then here with this method and with this command, you can see that here there are 16 missing values NaN for this column. We find it and then drop them, and the result is here 683 rows. And then creating the histogram using latent hist and alpha for transparency, creating histogram for just for these two columns, the size and shape of the data, and then importing Seaborn in order to use a joint plot to create the joint plot for these two columns, these two data, and here you can see the result. And then here we use just the first element of shape with this command. You can see this number means all the rows, and then just using a 90% of rows for train data, and using a like, which here means that's all the rows, and then just 90% of the rows, and here are the columns, and you can see here the shape changed to 600 and 11 columns. And then for testing data, again using like, all the columns and the rest of the data, and you can see here the shape is 83 rows and 11 columns. And again using to numeric, that I think we already used it, and convert the string to float number here in order to use this column too. And then for my features, which here called it X, all the columns instead of ID and class, and then for label just using the column class. And here again you can see that all the data types is integer and float, or are numeric, and here you can see the result for y, my label, our label, and then from scalar model selection import train test split in order to split the train, feature and label for train data and test data, and put the test size here in order to just use the 20% of the data and random state equal to 0 for some shuffling, and then this command and import a logistic regression and using it as a classifier, and fit the label and feature, and then predict the this data for test, the feature for test, and name it ypred, and then here using confusion matrix to comparing the true label. Here we called it ypred, and then predicted, sorry, here is the predicted label and here is the true label, and for comparing we use confusion matrix here, and then here this array means that we have six ones that not matched, and for reaching to the accuracy, we add this number to all, and then reach this number 95% for accuracy. And then again comparing the predicted train and the true train here with confusion matrix, and here using this command and adding this number, and you can see the 16 numbers mustn't match, and then here some calculation to um, receive the accuracy, and accuracy is 97%, which is a bit more than the test, and I think that's often or maybe always um, for training we should receive the more accuracy. And finally, thank you so much for listening to me, and I hope I could explain correctly, and I hope you enjoy my video. Thank you for all the things, and thank you for teaching this stuff to us as our professor. And it's really my pleasure to have you as my professor. And for this semester, I learned a lot from you. Um, that's it. Thank you.